Hello, everyone. Let's get started. My name is Chris Ott, and I'm filling in today for our Executive Director, Rick Harnish. I work as Deputy Director for the High Speed Rail Alliance. For anyone who might be new here today, we are a nonprofit organization. Thank you to everyone who already supports the work that we do. You help to make programs like this possible, along with all the other work that we do. We aim to be the best source of information about what high-speed rail and regional rail are, and the benefits that they can bring and how to achieve those benefits. We also support elected officials and other leaders working to make this a reality. And it's a really exciting time right now. Federal investment from the infrastructure law has started flowing to dozens of projects all over the country. And we now have not one, but two high-speed lines under construction here in the United States. The state of California's project and Brightline West, which broke ground in Las Vegas just last week. We are hardly the first, though, here in the US, and it always helps to learn from what other countries have done. And our speaker today has helped with the American projects that I just mentioned, as well as a great deal of, he also has a great deal of international experience that he's going to share with us today. John Rinard is the Transportation Program Director for AECOM's U.S. Western Region. He is a civil engineer and has served as an owner, builder, engineer, and consultant throughout his time in the railroad industry. He began his career on the Southern Pacific and later started the Southern California Regional Rail Authority's Metrolink system. He has led major programs such as the Alameda Corridor in Los Angeles, for the Metro in Riyadh, Saudi Arabia, South Korean high-speed rail, which we'll hear about today, and projects in Libya, Australia, Jamaica, as well as many in the United States. Here in the US, he was involved in establishing the initial standards for the Las Vegas to Southern California project, now known as Brightline West, and he transitioned California's high-speed rail authority to a new program manager. And just recently, he also received a Legacy Lifetime Achievement Award from Engineering News Record. So congratulations to John on that. If you have any questions, thank you all for being here. If you have any questions, please use Zoom's Q&A feature. That makes them easier to keep track of. And if you have a comment, please put them in the chat. And with that, let's turn things over to John Rinard.
Thank you, Chris. Let me see if I can tee up this shared screen here and get that going.
Yeah.
Is it working? Not yet. Not yet. Come on. There it is. Okay.
There.
All right. Thank you all for coming. I think a little bit of the background here is I simply love high-speed rail projects. I think they are our next generation in rail transit, and their value, I think, is extreme. And in fact, I quit a perfectly good job to go to South Korea to learn about high-speed rail. So I love getting this opportunity to tell you of some of the things that I experienced on that endeavor. That was in 1999, so it's been a number of years. We can talk a little bit about what they've done since then, as well. However, the Hanguk Kosuk Cholto, if I have any of my Korean friends on the line, that's a poor way of saying the Korean high-speed way or high-speed railway or high-speed steel way, but that's the term we would use, Hanguk Kosuk Cholto, and a magnificent project with that. In Korea. Now, let me first compliment or talk about the Korean people. I think they were amazing. They are dedicated and hardworking in literally everything they do. I don't know if any of you've had a chance to spend some time over there and do that, but you know, their whole country had to be rebuilt after the war. There wasn't even a brick on brick, as some people say, and it's in a magnificent country, and Seoul itself is a magnificent city. They're very proud people. They're hardworking and proud. They'll challenge typically everything with that. So I really enjoyed working them with that. Technically focused. You know, here was a project that they determined for the nation. Now, and we'll come back to that. The nation, not a state, but the nation, that would run from Seoul down to Busan at the south, a little bit to the east of the country, but basically right down through the center. But they technically focused on that alignment, on how it should be, and so they went after it, and they stayed with that as well. The people themselves, it takes a while to get to know them. They're their own people. They're very proud, so that takes a while for basically you to share and earn their trust and commitment as well. but I found they were a caring, friendly, and of course, if you like kimchi, it really does help. It's interesting that this project was the one project that did not stop during the crisis in the 90s, the financial crisis that struck most of it, but particularly the Asian rim was one of those. They kept digging these tunnels. You'll see that over 20% of the line is in tunnels. They kept excavating those tunnels. Not typically TBM, they were drill and shoot applications as well, but a fantastic group of people, and I really enjoyed being there with that. But the Korean High-Speed Rail, or KTX, is what it really talks about, was in 1992 is when they originally started it. And then in our role in 99 to 02 was to get that 100-mile test track up and running to where they could really burn in the equipment and the systems as well. So we had that test track operational in the year 2000. Commercial service went on April 1st of 2004. The line, which runs, I'll show a map in a minute, runs from Seoul to Busan, is 2 hours and 15-minute run for that 259-mile system. And it operates at 186 miles an hour across the line. And we did test that to 220 miles an hour. The system itself, apologies for the map, it got a little bit blurry when I blew it up, but the dark blue line from upper left to lower right is that original main line. They did have a parallel freight line that they tracked throughout with that, and of course their plan was to move those riders of those trains over to the high-speed rail line and let it run. And I'll mention they have been overwhelmed with ridership, and in fact today they are looking at doing a bi-level car to put twice as many people on those trains, and they are 20-car trains that we'll talk about in a minute here. But the system itself is the 25 kV. It's an overhead power fed system. The gauge is the standard gauge, 4 feet 8.5 inches. And then South Korea did provide the rail for that as well. The viaducts, 20% of the line, are 51.6 miles of those, so massive viaducts, and it's not uncommon to come out of a tunnel, go across a farmland, and go back in another mountain. Very, very mountainous terrain across that line. They used conventional ballast tracks, something that I think that high-speed rail should be cautious of. There's a lot of pressure to go to slab tracks, for example, but they stayed with the ballast tracks with that. And we'll talk about a little bit of the challenges with that. Two major tunnels incorporated on that line as well for 20%, approximately 20% of the tunnels as well, within two major tunnels over 6 miles apiece, but many smaller tunnels. The rolling stock was initially the Alsom's TGV, and later on they domestically developed what they call their HSR 350X. This is the Koreans developed this, where they achieved the 219 mile an hour in test runs later on with that. Now the next generation KTX, which is happening, went a little faster in 2013. They kicked it up to 253 mile an hour, and you know that Korea has been into manufacturing and delivering some of their own rolling stock, so that is what we see today along that system. So, but I think for me, the beauty of this project, like any project, is twofold. One is I just love working on these great big programs, and really what I enjoy is working with the people. So it wasn't me so much as a lot of very good people from many different countries of the world coming together to help with the management of this rail type with that. But some of the challenges, well, in this particular case, we had 4 languages involved, and probably a few more, but we actually had a French provider with the TGV, German engineer supporting that operation with that development application brought across. Korean, or Hanguk, was the language of our owner. And then, of course, we were English, and fortunately, the contract was in English. So that was an interesting thing. However, I did go to some meetings where I would have to take 2 translators with me to be able to converse at the table at that time. So it was a managerial challenge. A little bit more on the technical side, though. We did have a sway issue. A sway issue, as most of you may know, all railroads have that embedded wavelength in front of the train. And that comes out, in this case, at about car 11. I mentioned that the Koreans run a 20-car train. Now, that's the longest high-speed train in the world, 20 cars. And so that sway came out at car 11, and it was a challenge. Earlier on, the French had provided a AB car in the middle. If you don't know what that means, that's where you're able to separate the train in half, where it has an extra set of bogies underneath it where you can split that in half. And that is thought is also an easy way to dissipate the sway that then comes up in the train. But what happens to that wavelength, it ends up to be a sway left to right of the train. And I will say on the first train at 220 miles an hour, it was a very thrilling and scary situation with that sway. It was that strong. The train was literally trying to jump the tracks. So the good brains went to work on how to solve that sway. Another issue was we did have ballast lift. Ballast lift is where the air speeds and pressure under the train will lift the ballast. And eventually, one of those rocks lands on the rail when the wheel hits it at these high speeds that we're talking about. And we saw it because we had what I would call bruised wheels, where the wheel looked like a 50 caliber struck that steel right in the middle of that. And for a little bit of time, we couldn't figure out what that was until we were riding our test trains and we heard the tinkle, tinkle, tinkle of the rock being lifted onto that. The immediate cure was to upsize the stone, a little bit larger stone, and also sweep the rocks down below the top of the ties, or if you're my European friends, the sleepers. However, with that, it also caused us to how to look at that. And what the train manufacturers did was to change their louvers underneath the train to help us with that wind pressure that forms underneath there on that ballast lift. So with ballasted track, that is one issue to be dealt with. Transformers, I mean the transformers in the power car. So these trains have a power car at each end. They have a transformer inside there. We had a problem with the metal in the transformer itself, and it was overheating. It literally was peeling the paint off the side of that cabinet as one would walk past it. So we had quality control inside those trains. A side note I should add is, so they'd contracted with TGV to bring trains over from France. The first train was then going to be run, and I can't recall, but I think it was 400,000 kilometers where it would actually be in service, and then pick up that train and ship it to Korea, which they did. Second train, a manufactured train, complete and shipped, and then parts and pieces of the rest of the fleet. And the Koreans then from that learned later to build their own, as we talked about. The OCS is overhead catenary system. We had quite a little challenge between the OCS build and the civil guys building the base poles. That was a little bit of a challenge with quality control on that. But as everybody knows, the top of the rail and also that wire overhead has got to be nearly perfect. So having everything build up to that, including the catenary poles, was very, very important in this particular case. And we had some pretty good interface problems with the civil contractors with that. The Koreans tried to use everybody in country they could. I mentioned they dug their own tunnels. They manufactured their own rails. They manufactured their own ballast rock. They did their own communication as well. Hotel power materials. We had a problem. Hotel power is the power line that feeds from car to car throughout the train. And we had a problem there where we had aluminum fixtures up against copper feeds, and it became a hot spot on the floor of the coaches, and so hot to the point that we had to fix that as well. So those are a little bit of some of the main points of some of the challenges. Now I have a whole lot more though, and a bit of this is some of what I recommend moving forward with my short time at both Brightline and at California High Speed Rail. It's all about the standards. If you've ever started a railroad, and I had the luxury of starting with the Southern Pacific, where they kind of beat it into us, but realize our client was the operations. And yes, it's the bums on the seats, but it's the operations that we need to do that. So that standard is very, very important. I believe as a nation, we're being challenged to step up to the high-speed rail arena out of a group where has in the old days built freight tracks. Then we went to light rails and commuters, and now we're trying to do the step up of the high-speed rail. And I believe we need to challenge some of those standards and not just accept them for what they are. And I'll mention a couple of those where you can ask questions. Drainage is always the first three rules of any railroad: drainage, drainage, drainage. The Koreans took that on very strongly as well. So whether the drainage be on the deck of the structure or alongside the embankment, high speed needs to have the best of the best, and drainage still is the most required. We cannot afford to put a 220-mile-an-hour train over top of an embankment that is ready to be coming apart because of poor drainage. That's critical as anything else. I particularly mentioned cable trays. I think we're struggling with that. My point on that, and you'll notice the pictures that we showed here, Korea doesn't have cable trays. They're buried. It's buried in the ground. And my example that I mentioned to other engineers that I've worked with on these systems, I will ask them, why a cable tray? And they said, well, that's what we do. I said, but let's challenge it. Why? And actually the answer comes back, well, we need to get to the cables. And my statement is, no, you don't. You don't want to get to the cables. You want to get to the end of the cables where they hook to the solid state hardware in the cabinets and whatnot. That's what you want. I believe for a cost savings and for a security and maintenance, they should be buried. Now, realize that most other countries of the world are dealing with, let's say, 50 miles of a line, of a high-speed line. But the United States, we're dealing with hundreds of miles. And I think we have a different issue there. So if we lay cable trays, for example, on a double track, a couple of these systems want to lay two cable trays, which usually are a box underground, sometimes precast with a lid, for hundreds of miles. I think you can see the cost. But my point is the cost, but also the ease of security is why. So I think cable trays thought in those standards is a very key point to think about. The track itself, there's a lot of this track you'll see, particularly California high-speed rail. There's a lot of direct fixation track, for example. But I would say to give caution on that. Number one, we're probably on a new embankment, an embankment that has not been there. So unless we've taken the years of surcharging, we're going to have secondary settlement of those embankments. So if we put slab track on top of that, we're probably going to waste our dollars and it'll probably break and come apart. I highly recommend that the first phase we build out with ballasted track, including the structures. And the reason I say on the structures, typically in California, we have something called earthquakes. And with keeping ballast on the structures, it allows us to then be able to absorb a small crack in the deck of a bridge and possibly limp a train across the top of that while we then get it fixed. But if we're direct fixation, we have much more of a problem dealing with that as well. So I highly recommend taking a look at that as well. Structural designs, I would challenge most of our engineering and particularly our consultant firms that are working for those to always think about O&M. Always think about O&M. And it's classical that I'll be asked to take a look at a system and I'll ask what the design loading on the bridges is. And those railroad people on the line will know that traditionally E80 is what I like to hear. E80 is the freight train loading criteria that's used in AREMA and other places. It's developed from the old steam trains of nose to tail on multiple tracks with the dynamic loads. But O&M. And a lot of times I've ran into where some of the designers said, well, we wanted to save money, so we designed it for an E60, E40. And I understand that, except the problem is then in your maintenance or your rehabilitation maintenance. You need to be able, for example, Brightline's 200, 250 miles of a single track. So it's going to be very important that when they do have to rebuild the track or sprinkle new ballast or bring out new rail, they need to get out there with a big diesel locomotive carrying probably 10,000 tons of rock on their back or a load of ribbon rail, and they got to be able to go over those bridges. So those bridges should be designed, in my opinion, for that E80 loading so they can do that. But also then the other side of that structure is recovery. And what I mean recovery is if you have heavy maintenance or you have an earthquake, for example, or if we're in Florida with the hurricanes or Texas, those are all things to be thought of. And if you take a note of that, I joke with my Caltrans friends about, well, what happens if you have a broken bridge on I-5? And they say, well, we exit the cars at the last exit, we loop through the neighborhood and we come back on. Well, you can't do that with a high-speed train. So our whole system would be shut down. So I would really look at that within our structural design as well. All the designs, but definitely the structural design. The embankment settlement, I mentioned that already. It is something that is critical. A lot of people say, well, we won't have derailments. We'll do certain things. We'll make it safer. We'll use some guardrails. Well, Google that, high-speed rail derailments. They happen. They happen more than I would have thought about. But that embankment settlement, I think, is something that we engineers really need to think about over time. And then after that first round of running it, maybe it's 10 years out, 20 years out, we can come back with the slab track. I think that's the time we know that our ballast is tight. In Korea, what we did on the 100-mile test track, then what we did, the test track was centered by the source of the rocks, the sleepers, the rail, and then everything went out from there. So they ran those work trains on top of that embankment for years, if you will. So it beat down that embankment. I think it was an excellent idea that the Koreans even taught me on how they applied that. That ballast design, I think we mentioned the bigger rock. In Korea, we stepped it up. Now, Korea has fantastic granite stone on most of those mountains. It's a source of great rock. But Las Vegas and California, it's a long ways to run for any granite rock. And any lesser rock, you still got to go all the way to Utah or Wyoming to get some decent rock. So the cost of that is tremendous. But what we had to do was step up the size of that to take care of that ballast lift. We lowered the profiles to also help with that. But the train design, the louvers underneath, need to be specifically looked at that as well, would be the recommendation. Control houses. It's always interesting that we build bridges, but then we forget about we put a crossover up on top of that bridge, and now we got to place a house. It sounds like it's trivial, but yet it's made the mistake where all of a sudden we forgot to put a house on there. Now, high-speed rail systems with triple redundancy of failure take a pretty big house. Sometimes they can be as much as 10 by 30 feet. So if you're up on a big structure, where are you going to put it? So you have to, again, you've got to think about O&M. And a lot of people don't understand the single maintainer needs to plug in his laptop and go out on the switch and do that 3 or 4 times per week. And so locating those appliances along the rights of way for easy access, for rehabilitation are critical. And the Koreans did that quite well. It was fortunate in Korea that they had a whole lot of their Korean railway people rolled over to the Korean high-speed rail system. So that would be like a class 1 in the United States coming over to a high-speed rail. So they brought a lot of that knowledge with them. But I think we are challenged in our industry where a lot of our new and young engineers, great sharp people, are coming from our consultant groups without that initial knowledge of railway operations and the critical nature of that, whether it be dealing with the FRA, maintenance, rehabilitation, all of the above do that. Rail itself, it seems to be an interesting thing. The rail, typically, I think we have wonderful rail coming out of our rail plants for our class 1 railroads. As you all know, probably 136 pound, has a larger head. The larger head allows us to grind it more, so hopefully the life is longer. Maybe what you don't know is a rail, if taken care of, usually will have 1 billion tons over top of that. Now with high-speed trains, they're lightweight trains instead of the heavy freights. So that rail, if taken care of, should last a very, very long period of time. There's some question about whether our rail qualifies to carry a train of 225 miles per hour. I think that's the wrong question. I don't believe it's the rail that we're talking about. We're really talking about the metallurgy inside the rail. And I believe our U.S. rail sources are as good as any that we get overseas as well in that. And so I think buying that material locally, of course, really saves on the budget side of that. Impact wall designs. My point there is it was discovered in some of our workings that, and the easiest example is when you drive along your interstate and you come up to a bridge, you'll now see the K-rail that is developed from guardrails to twisted ends to buried ends. Now you also have the K-rail that then is buried into the ground. Well, the same thing on the high-speed rail I would recommend, because if that train ever does come off, and we did talk about that it does do that, those trains are high speed. They're typically lighter weight bodies. So even a blunt object very wide is going to cut right through that train, and the tragedy would be huge. So those designs need to be thought about that. So whether it be a tunnel entrance or coming up to big piers on bridges, I think those impact wall, which really, instead of an impact, it would be a glancing blow, and they will derail with that. But that's some of the challenges with that. With that though, that's a quick explanation. But let me talk a minute about the organization itself, as I could. I'll come back to this sheet here. The organization of the people, I think, is tremendously important, because we are now developing high-speed rail in arenas that we're stepping up to that. And I believe also, though, with that, we run into things like Buy America, U.S. contracting methodologies, things of this nature. And my joke on a focus of that is, I was asked one time who could build the overhead catenary system for one of these high-speed rail systems, and I said, well, our big companies can. And I was actually challenged that said that only 2 international firms could actually build what we want to build in overhead catenary electrical distribution systems. And so I mentioned the gentleman, I said, but at the end of the day, the Brotherhood of Electrical Workers are actually going to be the ones to build it. What we need to understand is to how to get that quality to that highest level, whether it be the catenary at the top that I'm talking about, or the quality at track at the bottom, near perfection, which is what it needs. And every contractor does want to get that perfection in there. The issue comes down to, did they run the quality from cradle to grave and really develop it with that? But those type of applications with the teams we have really, I think, get us the best result. And I think we're learning in that. I've learned a lot over my years in the high speed since '99, and wow, that's been 25 years already. But with that, I hope that's a few of the things that I've looked at and discovered over the years, and maybe it's of value. I hope it is. Thank you, Chris.
Yes, it certainly is. Thank you, John, very much. And just as a reminder for everyone in the audience, if you have a question, please put it in the Q&A. We'll get to as many as we can. John, I wanted to just kind of kick off with a couple about your experience there. How long did you live or spend in South Korea?
It was just short of 3 years.
3 years, okay.
But we did the 100-mile test track startup, and it was a fantastic time.
Okay. And did you go in liking kimchi, or was that a taste that you developed along the way?
Actually, they have a Chinese red pepper sauce that goes on top of it. And I got to tell you, I got hooked on that stuff. And that is amazing. But they've got about 47 different varieties of kimchi, some of which I liked quite well. But whether it be bibimbap or bulgogi, I enjoyed their foods. It was good.
All right. Good. You must have for being there for 3 years. Let's see. Howard has a question. It's a sort of general question. What are your thoughts on the high-speed rail coming in California and Las Vegas to California?
Big question. Well, as I mentioned, I love the high-speed rail. I believe what I've studied is if you can have big cities from 250 to 400 miles apart, I think that's where the magic works. That fits California real well, LA to San Francisco. The challenge on that is we got to poke through those mountains down to Tehachapi Mountains, coming into the San Andreas Fault and all that into LA, because I believe something like 65% of the people live in Southern California and 35% of the people are north of there. So without that linkage, which is so far a huge tunnel cost to get that done. So I believe it's going to be magnificent. My career of 41 years building all kinds of rail, by the way, every one of those systems are clear full of people, whether it be in Denver or Seattle or Florida or Texas, they're clear full of people. I expect this project to be magnificent, and hopefully they'll forgive us for the time it took to build it and the price it took once we finally get it started. I also believe that the California high-speed rail should have been a project of national significance. I believe it's too much for one state, even a state with the resources of California. I think it should have been a project of national significance, and I think we've maybe there's still hope in that, but I think that California high-speed rail. Now, The Brightline operation, it's a special application. That's a Las Vegas to Southern California move. That is a dedicated customer. That's not designed for your people commuting to work, wanting to buy an $8 train ticket. That's not the design. This is a captive audience. That's where the capital cost is much more. So that's a single track railroad, by the way. Single track railroad, I believe it still is, even though the price has gone up. So that is a captive audience. They want to offer a first class type of service for the resorts in Las Vegas back and forth. It's totally different. However, I do hope that the two standardize their works with each other. I think gauge is going to be, but I worry about the train controls and being able to intermix the trains. California High Speed Rail has, I believe, about 6 different commuter operations that they want to come on top of the tracks as well. So there's a train control compatibility issue. Whereas Brightline, maybe not so, but we did convince them to go from Victorville down the hill to Rancho Cucamonga, where they do link up then with Metrolink and the MTA assets and San Bernardino assets at that point. So they're 2 different applications. However, they, I believe, are setting the standard for high-speed rails that then will hopefully over my kids' generation be built across the United States. I think it's time to come. You've been on our highways. The right-hand lane is for trucks and the left-hand lane is for cars. And so I think we have that challenges. But I think those 2 projects are fantastic. I track the Texas application as well. I believe that when we finally can get the first one done, and California's a big one though. It's a tough one to take on first, but I think they're both magnificent. And I think they'll show their worth. So hopefully that was a good answer to your question. If not, ask again.
Thanks. And you spoke about how projects like this are, too much for one state, or they have national significance. Robert asks a question that I guess comes at this from another angle. He says, "Can you address the issue of stakeholder alignment? Most public agencies utilize traditional design, bid, and build. How do you get agency departments on board to alternative delivery methods?"
Wow, big question. Good question. Well, you can probably tell from my picture, I'm a little bit old school. And I have built 200. I've been blessed with managing one way or another 220 billion in construction, not counting Brightline or California High Speed Rail. But I believe we are chasing our tail a bit in the alternative delivery. I think we're trying to look for something that's not out there. I think we want to come up with a contract mechanism that has no cost overruns and no lateness. I don't think there is such a thing. I really think it's the people that you put on the contracts that manage those projects. Now, I've been a contractor with CMGCs and Progressive Design Build myself. I purposely did that to experience that. And I love those because you just took the competition away. And so now we're going to be competing about whether or not my production rate's to your liking or not, if I'm a contractor. I struggle then if I'm on the owner side, whether it be the consultant or the owner side, on how to manage that. I love design, bid, build, I got to tell you. Now, by the way, my design build friends will tell me, well, but design build's cheaper and faster. I will challenge them to that. Show me the facts. Don't say it. Show me the facts. And I don't think they can. You can get lucky. You can get lucky. And in my history, I built out the Metrolink system there, over $3 billion. First line was open in under 2 years. The whole system in 4. Alameda Corridor, again, a $3.5 billion project. Record time, no claims, no litigations on either. And what the agencies really want to do, I think, is move the risk. They want to move the risk. The problem is we can't afford to move the risk. It's just too much. That's what is that? A FIDIC red book? You can't afford that. So I'm really down on the alternatives. Now, if we have to do that, I do love a progressive design build, but I'd rather do it hard money. On the Alameda Corridor, the first design build contract in California was the deep trench in the tunnel section on the north end. It was 10 miles on the north end. And that was a hard money. In other words, an actual bid price for the first phase was the design, get it accepted, and then get it built. We had to have a total price because we wanted to sell bonds out into the bond selling market. So we had to have a whole price. But we knew there would be a slightly increase because the contractor is picking up a piece of that risk. That worked very well. There was zero litigations on that as well, but it was a unique type of a progressive design build. But we kept the competition in there. In fact, we had 3 finalists. That was $1 billion contract. Well, that seems small today, but that was in 1994, and seems small today. But I don't believe the alternative delivery are gonna satisfy all that we think it is. It's not going to make our problems go away. We are engineers. We deal in infrastructure. We deal with underground. We deal with change conditions. We deal with third party. And I always joke with my architect friends that build a tall building. If you can put a fence around it, and once you get out of the ground, God bless you, you can build that thing all the way to the top. None of my projects you can put a fence around. None of them. It's too many miles. So every inch, every foot, every mile, you're exposed to more and more liability. And whether it be a windfall profit for the contractor or litigation for the owner, I think that's where the good, strong teams can be in that. And a side point to that, if an agency does, and I've given many presentations on this actually in the last few months on alternative delivery, and what I also tell them is, when you as an agency decide to change your contracting methodology, you have a learning curve as well. So your staff now has to learn how to deliver a CMGC or a progressive design build or a triple P. And guess what? They're not $100 million anymore. Those are billions now. So you don't have the learning curve time. So if you do make the switch, make sure you got your staff ready to handle that new change, and it's not the work that it was yesterday. It's a challenge there. I know a lot of people want to do that because they want to bundle it, get it out the door. There are reasons for that. I mentioned selling bonds. We had to do that, but I still think traditional is the way to go, where you can define it, you can manage that risk throughout and deliver it. So hopefully that answered the question. It's a big subject.
Thanks. And in the course of answering that question, John, you mentioned a number of projects that were completed, mentioning that some of them were completed in record time. And so this next question is about timing, I guess. Here in the US, some of our passenger rail projects take quite a bit of time. David, an engineer in Chicago, asks, can Brightline West be finished in time for the 2028 Olympics, as they aim to do?
Good, but it would take an awful lot of people pulling the same direction. I will say, David, that the challenge on that project is not the technical. It's not the pouring of concrete or placing of steel or building of tracks. The challenge is their plan is to go down the center median of I-15. A wonderful idea, and that's beautiful. So you don't have to buy the property cost, but now you have to satisfy the Nevada DOT and Caltrans in California. And that is a third-party challenge. And with that, David, I would say it's going to be difficult. Now, if the champions of the project can include the state of Nevada and the state of California, it can be done. But they have to solve the issues immediately. And the tug of war is, Brightline is a private industry, and if Adrian's online, I'm still wishing him well. He's the engineer heading that up. It's going to be a challenge, and I know he's wrestled with those over and over again. So you're setting the stage. Unfortunately, a lot of our transit lines end up to be, urban renewal type projects, and we have to tough it out and get through those things. And when they are done, they're magnificent, but it's a long trip. I think it's going to be a challenge. It could be. There's a lot of goodness about that. It's private. They can cut corners and time and all things of that nature. It's going to be a big challenge. Leave it at that.
Okay, thank you. Brian asks, is South Korea expanding its high-speed rail system?
In fact, on that map I showed Brian, those feeder lines to the sides are follow-on high-speed rail lines. Yes, they're getting a little slower. If you remember the French, I think it was back in the 60s, the French president did a study about what can they do as a nation to attract more tourists and keep the tourist business going in France. They came up with the high-speed rail program. So they built their first line, and then second line and third line. Now what they've done, they've made it even country lines now, and it's become the national railway, and that's also taken on into the neighboring countries as well. So I think that is where they're going with it, and Korea has. Now, I also mentioned they're looking to double stack the seats. You remember, I don't know if the real train guys go back to the Bombardier gallery cars where we actually had them stacked. I know we had them in Chicago, we had them in San Francisco. They want to go back to that, to where they can stack those seats, and they're trying to develop that car. I believe it is developed, where they can stack those and double the numbers. So it's been tremendous. But yes, line expansion as well as higher volumes on the lines themselves.
Okay. Thanks. And David had a follow-up question, which I didn't see in time. So back to that. He says, it seems like the California High-Speed Rail Authority has changed the way it manages procurements to be more conventional. For that project, does that make you feel better?
I guess I don't know what, well, conventional would be older school, I guess. That would make me feel better. I think they have 3 big design build contracts out there, and I believe in that case they were monstrous jobs and very challenging, and I think the staff really did well dealing with what they had. They had some property acquisition problems that tripped them up. Environmental clearances did get pushed out real well. I really admire them. 2 thumbs up for that. I think in the industry, I don't know why, but and I think it must be because of time. But let me answer it this way: if I think the best thing to do in contracting for the construction market, and by the way, all the contractors are busy right now. You got to be careful with that, because if you don't have contractors don't just sit around waiting for a bid. They got to keep working. So you're trying to fit into their timeline. They're not fitting into yours. They're trying to. But so if you've got a bunch of bridges, why not let bridge builders build those? If you got a bunch of track, why don't you let track builders build those? You know, same thing with overhead catenary systems. Let the specialty build them. But when you start getting bigger into the $1, $2, $3 billion, you're also combining the technical areas of structures, earthwork, tracks, maybe systems inside there. And I think with that, you're then typically keying up joint ventures of management, and you're throwing in design as well. And, you know, design and builders, they don't even understand each other, you know, and now we're doing a forced marriage here. You know, forced marriages don't work too well. And so they force those together. And I think we're struggling with that. Now, if we were in the 100, 200, 300 million, maybe up to $500 million range, I think it would be easier for us. But we're not. And the problem with it is everybody believes, well, I got to get this thing open, so I'm going to put out this $5 or $8 billion contract. But I'm here to say that the contractor is going to follow the longest pole in the tent. You know, he may get a whole lot of other smaller poles built, but the longest pole in the tent is what's going to dictate the schedule. And that's at risk. Whereas if you uncouple those pieces, maybe you can do better. And I believe you can. And I think a flatter organization, in my experience, works well. I've managed up to 226 contracts at one time. That happened to be in Libya, of all places. But you can do an awful lot when you spread that out. But when you put it all underneath one tent, I believe the tent gets stuck on thinking about that one long pole in that tent, and it delivers on that. So if I know the COO there is trying to make a change on that. He's actually following some of the recommendations that him and I talked about a lot. I really admire that. I think that it'll be interesting. They're under a Buy America criteria, and that's going to be a challenge. We don't provide high-speed rail cars, you know, technically in America. We do final manufacturing here. So all of those things are going to be a challenge. I think if they can get their 171-mile test track up and running, and by the way, start giving us rides on it, that'd be great. But I think the look at the contracting north and south will be a challenge, always will be a challenge. And that's what we're challenged with as engineers, is to keep supporting that. So tough question to answer, David.
Well, thank you. Eric asks, how feasible is this type of high-speed rail system in the United States generally, and maybe specifically on a high freight corridor like from Chicago to Rockford? And then Eric has a sort of related question: is an interconnected network possible, such as from Chicago to Nashville to Atlanta to Miami?
Big question. Good question. Has to remember how we in America were started with trains. The trains are private. They're private businesses. They have to make a profit. They thought during the 90s, when commuter rails rolled out, that commuter would be a good partner where they can share overhead costs and dispatching costs and maintenance costs, things of that nature. What they found out was whenever they had an accident, it cost them dearly. So today they don't want to have much to do with new start commuter rails. You haven't heard of many new starts on class ones anymore. So the shared right-of-ways are difficult. And most of those right-of-ways you mentioned are class one owned. So that's a difficult thing. We happen to own the interstate rights of ways. That's what we built. We got the white pavement out there to haul cars and trucks across America. Can it be mixed? Technically, yes. Are there challenges? Huge challenges, because the higher the speed, the more difficult to mix with a freight track. Freight track top speed 79 miles an hour. Northeast Corridor, I think they're pushing 150 now. I think they're pushing 150 on that, but that's only with passenger trains. And that's after, centuries of attention to try to get that speed up. So it's a challenge. It's a question difficult to then see the result of, because of all of those challenges on how we do that with a new right of way. I mean, I think it'd be wonderful if our country came out with an east to west high-speed route that gathered from the West Coast and distributed to East Coast back and forth. I don't see that happening anytime soon. And however, if we had to build a third lane on our interstate highway system, high-speed rail is probably going to be cheaper, except they've already bought the property for the high-speed rail. So it comes down to property. And our cities are mature. To get to the heart of the city with any sort of a new rail system, you just can't afford it. You're stuck. You're dealing with tall buildings. You can't do those things. And so can the mixed service be run? Yes. In fact, there's many of them, from San Diego's trolley to the Tri-Rail down in Florida with the CSX to the UP with the Metro in Chicago. You have them all over, but they're really grandfathered in. So I think us to grow out to improve on that is going to be most difficult and probably very expensive.
Okay. Related to that, there was a question about it's essentially, do you think that high-speed rail will ever have a national funding mechanism like the interstates that you just mentioned too?
I believe it needs to. That's where I was talking about a project of national significance. I believe we've bitten off something in California. Brightline's a little different. That was a private entity with a special customer, Las Vegas. And I believe California High Speed, realize it's 800 miles long. It goes from almost one end of California to the other. That is a railroad. That's not an LRT in downtown U.S. City. This is a railroad that crosses. In fact, you probably don't know, but they need 4,000 miles of rail, just a rail, 4,000 miles. They're big, and so do the math on the rock and the catenary poles and the cross ties. It's huge, but the national significance, I believe, is really the answer, and hopefully it will step up. Now, California High Speed Rail does get considerable money from the feds that comes across, but I think there's a difference between having champions at the federal level versus champions at the state level on something of this magnitude. It's too big, I think, even for California. So I hope it's there, and I probably would be one to volunteer for some taxes on that, but I'm a rail guy. So
all right. Well, and related to that, incidentally, for anyone who hadn't seen this news about a month or so ago, but Representative Moulton and Representative Del Bene introduced the American High-Speed Rail Act of 2024, which would provide $205 billion over a 5-year period for high-speed rail. development. It's, has not passed yet, but there's there is at least some legislation in play. And we here at the High Speed Rail Alliance, one of our top objectives is to establish a federal railway program to provide the kind of federal guidance and also sustainable financial support that that we used, for example, for the interstate highway system. So that is a top objective for us. Howard, moving along. Howard asks, what are your thoughts on international service, for example, Seattle to Vancouver?
I think it's a growth out of Howard of hopefully what gets started. If California were to get built, Brightline's a little different because they're private, so they're like a class one in some senses. But if we get the California build, so we had that backbone, if you will, running the full length of California, I think reaching north to pass through Portland, Seattle, and Vancouver on up is a likely, and I think much easier to do then because we've got the base piece sold. And the other end, also heading east, I think also starts to happen. I think that's what we want, I believe, is connecting the major cities. Our Western United States fits better in the definition of high-speed rail because we just can't carve our way into downtown New York City. It's just, we got skyscrapers in the way. And so then that pushes us underground. Well, the price underground is 100 times more than at grade. So we're stuck with that. So I believe we can use the light rails and the commuter rails as feeder systems of big cities. And then the high-speed rail can be that transcontinental system as well. But why not link it to our friends to the north as well with that? I know that Northeast high-speed rail is trying to get some traction. And so to make that linkage, it's only a few miles. A couple of good engineers can figure that out. And a lot of money.
Mm-hmm. Okay.
But yeah, I think it's where it's going to go, probably after my lifetime.
All right. And John, you shared some of what you learned a lot of what you learned in South Korea, but this seemed to leave people wanting more. Roger asks, can you say more about standards for high-speed rail here in the US? What can we learn from other countries?
Well, I think the biggest thing, like I said, I was taught on the Southern Pacific Railroad, and we live with the standard. It's developed over 150 years. The chief engineers take them on personally. It's very, very difficult to change. And if you think about it, let me give you an example. What's the catenary pole look like on the California high-speed rail? Well, it could be hexagon, square, H-pile, could be concrete, could be steel, all the above. But probably the cost effective is to have a standard pole with a standard supplier that then competes that pole over time. So that's a standard. And I think it would look a lot better if the pole was the same pole from one end of their system to the other. Now that's an easy one. But the standards are something that I believe give the designers the definition of what the owner's operation wants to have. And if you go to any class ones or typically your commuter rails and even your light rails now, you can be handed a book of civil standards or system standards, and that would be 90% of what they had. We don't really have that in high-speed rail in the United States. And a lot of people say they do, but usually it's lost back in the inside of that computer system someplace. And there's too many revisions and things of that. But one thing about these large hundreds of mile long linear projects, if you don't standardize those widgets, then the price of the widgets gets out of control. So the standardization helps you with that. But on that, what kind of imbalance are we going to use on the tracks? What is the centers on that? What is the style of the sleeper or the cross tie that we're going to use? I mentioned the ballast lift. By the way, I think we should look at a deeper tie instead of a thicker tie just to help with that ballast lift issue. Those type of things. So don't be left so that every contract you could end up with another product, but it's the same product. It's consistent. What are the rail fasteners? The fasteners is what's hold the rail to the tie below or the DF track. You don't want to have 27 different type of fasteners when California high-speed rail wants to get completed. My recommendation to the COO there at California high-speed rail is they should procure like a railroad would. So they get the big procurement contracts in place, do a contract for the fastener, have a long-term contract with that. That's what the railroads do, and then buy it that way. And therefore keep your standard. Why? Then your stocking of the spare parts and equipment gets cheaper, gets organized, and it gets much more valuable to the operation. So it's not the capital cost, it's that operating cost down the line. That's the important, or some of the importance of standards that do that. One time I was given on one of the high-speed rails, I asked for a cross-section. And I already talked about cable trays, but this one was, I saw this big 10-inch pipe down there and had a cable lay in the bottom of it. Now, most of us rail engineers around electrical trains will know what that is. That's a grounding system for straight current. Well, if I'm out in the middle of California or the middle of Nevada, in the middle of nowhere, I don't think I need to have that system even built. Yet if it's on the standard, it's going to get built. So I think we got to be careful with that because we cut and paste, and then all of a sudden we're building something we don't want to build. I think we need to challenge that in those standards with that. Now, if we're running alongside a metal pipelines carrying gasoline, yes, we're going to have the straight current collector. But that should be covered in those standards, things of that nature. But typically it's your big elements, which would typically be your track and your cat poles and what's the distance out for your cases and houses and those sort of things. And that way people don't need to know that. I can give you war stories about doing that with consultants who, and you realize it was the late 80s that when our consultants or contractors finally started building tracks and systems work. And they didn't realize that the door on the house had to also be outside the clearance envelope. Well, everybody thought, well, the door's closed. Well, no, the door has to open. And the problem there is there can be fatalities with that. And by the way, that happened in San Dimas, California. And so learned the hard way there, had to move the house. But those sort of standards, which also give you clearance criteria, setback rules, overhead rules, all of the above, walkway rules, all of those are inside those standards. And then the multitude of designers don't have to worry about the basic elements, but they look at the standard book and follow that. Hopefully that helps, Chris.
Okay, thanks. And we'll try to get to a couple more. Someone using the name Just Build It and asked about Buy American, asking, are there companies in the USA that can build the rail cars that we need?
I believe there are. I think there could be some, I call them widgets, that may need to be imported. Definitely, possibly some of the train control devices that might need to be coming from overseas. But we're manufacturing now. I know Siemens has a manufacturing shop right here in Sacramento that makes rail cars. I would hope they could gear up for that, because that would be then American build system here. Hopefully they can. If not, at least the component assembly and final manufacturing for that can be, because you have a lot of expense in the trucks and gears and journals and whatnot that run that, even the seats and windows and all that, typically. So, but you realize what we're doing with high-speed rail, we're creating a new industry, and so those companies, whether it be rail cars or catenary poles or overhead catenary systems, all of those are, even the sleeper manufacturers, even the ballast, all of those, we're having to create that industry to support us. Whereas if we build a 22-mile long light rail in USA City, it's a one-shot, pretty simple. I call it we're on an island, but we're not on an island on these high-speed rail. We're crossing state lines and hundreds of miles. So I think I'm hopeful, and that industry, we want that here, right? It's the best, and we've got good people. Like I said, the Brotherhood of Electrical Workers are going to build the OCS system on the California high-speed rail. The question is, who pays it?
Mm-hmm. Okay. I liked what you said about we're building an industry here. And alongside that, David had one more question about the ownership of the alignments. Do you think high-speed rail alignments should be publicly owned?
Yes, I do. I think that gives us flexibility with that changes that happens in the future. And I think it's vital to do that. What the railroad taught me was own the land, and I didn't know why. And when Metrolink came around in LA, by the way, the counties own that land, and that's really paid off. So it's paid off. If you own the land, you own it. It's yours. You're the ownership of it, and you get to dictate what it is. There was some challenges with that, but I think that's vital. Yes.
Okay, thanks. Well, we're not going to be able to get to all of the questions, and we have someone in the audience actually asked if you might be willing to share your contact information, saying they have a couple questions that might not be of general interest. I'll leave that up to you if you want to share that right here
Yeah,
now, or else.
I have no problem.
Okay.
My phone number is 208-392-3178. 208-392-3178. Best thing to do probably is text me there, and then I'll hook up with you. And how's that work, Chris? That'd be okay.
Great. Well,
I don't have a problem answering questions. I love this industry, and I really believe in high-speed rail. And I remember riding on that first train at 220. Now you remember it scared me to death with the sway problem, but it was magnificent. It was magnificent. And those trains are packed. They are packed with people. It is just, I think it's a renaissance in rail.
yeah. Well, thank you for being so open as to, give out your number like that. And thank you for sharing both your expertise and your love for this. It really shows. We really appreciate your being here today. And thank you to everyone who joined in, who tuned in today. And if you want to keep programming like this coming, please support our work. You can go to highspeedrail.us and click that donate button. That's what makes this work possible. And if you are, involved or, a representative of a company that would like to give or sponsor a talk like this or work with us in some way, we'd love to hear from you as well. But for now, thank you again, John, and thank you everyone for joining us today.